Welcome to qnawire.
Alright guys, we're going to be doing problem number 92, chapter 8 in Chemistry of Central Science. So following the three Lewis structures for NO2, we see them here. So using formal charts, which of these resonance structures is likely to be the most important? Let's put our formal charges. So here oxygen is -1, and here it's plus, and nitrogen is plus, because nitrogen is forming 4 bonds, oxygen is forming 1. Here, nitrogen, that's here, nitrogen over here, that's forming 1 bond, and they draw the yes, I drew the Lewis structure correctly. So our nitrogen here, this is going to be plus, this is going to be plus, and this is going to be 2 minus. 2 minus, because 5 minus 6 electrons, that's -1, minus 1 bond, that's -2. Now here, we have nitrogen, so 5 minus 4 minus 2, this is going to be -1, this is going to be +1, +1, 1, 1, 1, +1. So the one that's going to be the most important is the more electronegative element is going to have the minus charge, and that's going to be the oxygen. So this one is going to be the most important one. And the predominant resonance structure always has the electropositive element having a positive charge, and electronegative element has a negative charge. So the NN bond length in N2O is 1.2 angstroms, slightly longer than the N double bond, and the NO bond length is 1.19 angstroms. So NO 1.19. NN and this S and the NO bond length is slightly shorter than the typical NO bond. So based on this data, which resonance structure represents N2O? So the NN bond length is slightly longer than the typical N double bond. So that means that we're going to have a partial double bond interaction. And it means we're going to have a partial double bond interaction. So it's because it's slightly longer, that means we're going to have closer to a single bond. And the NO bond is slightly shorter than a typical NO bond. So based on this data, so it's going to be a bit it's going to be a bit stronger. So you actually are going to have a triple bond interaction. So our NO bond length is going to have a partial single bond and any partial double bond, and your NO is going to have a partial triple bond. So it's actually going to be, so it's not going to be like this because this is a double bond, single bond. It's actually going to be closer to this kind of structure. You're going to be, it's going to be somewhere between these two structures. So your actual structure is going to look something somewhat like this. And it's going to look something. It's going to look something like this. So we would have a slight as it's actually it's going to have a slight double bond for the NN interaction. action, and it's going to have a partial triple bond for this interaction. So this structure in the middle is actually going. So this structure that we have in the middle is going to this structure in the middle. How do I say this? You can argue this structure in the middle is going to interact, but we can't say that because we have a positive charge on our electronegative element. So we can actually put it over. So it's actually going to be closer to here. Here, it's going to be closer to. It's going to be somewhat close to. It's going to be. It's going to be. Sorry. It's going. It's slightly. So it is going to be. Sorry. So you're going to have a partial. Sorry, I misread that. So you're going to. So you're going to have an NO double bond, and you're going to have. So you're going to have a. How do I say this? So the NN bond length is for N2O is 1.12 angstrom. It's longer than the NN triple bond. And the NO bond is 1.12 angstroms, which is slightly shorter than the typical NO bond length, which now that I look at it, I think that might be a typo. I think that should be like NO with a single bond as opposed to a double bond. So anyway, so it looks like this structure over here, that's going to be based on that, it seems that this structure on the right, that may be the one that most accurately represents N2O. Because you have a double bond interaction, and you have double bond on both of these, and you do have a double bond on your N2O.